Good afternoon. I hope everyone's had a fantastic conference. So my name's Simon. I'm an engineering director at Eventbrite. And today I'm going to be talking about our ongoing migration from a single monolithic code base to an architecture based around smaller independent microservices. I'll be describing our progress so far, talking about some of the lessons that we've learned along the way, and I'll discuss some of the problems that we're looking to solve in the future. So I'll give you some background on Eventbrite. So in 2014, we helped sell over $1.5 billion US worth of tickets. We currently have just over 500 employees, and that's 100 of those are engineers and people in the sort of product and engineering department, which is a place where we're actively hiring as well. And we've been Python powered since 2006. The very first lines of code written for Eventbrite were in Python, and we've been using Python ever since. In terms of engineering, we actually have our main engineering office in San Francisco, but we have a major engineering center here in Mendoza. So if anything in this talk resonates with you, please come and talk to somebody in an Eventbrite t-shirt about the job openings that we have. But today I want to talk about software engineering. And when I think about software engineering, the image I get in my head is really something like this. That right in the middle is a giant ball of mud, otherwise known as a code base, and the people around the edges are software engineers, and they're trying to move the ball of mud, but you'll notice that they're not necessarily all trying to push it in the same direction. And this becomes more and more true the larger your team is and the larger your code base is. And the bad news is that there is no escape from this. All software is mud. I've never seen a code base that doesn't look at least a little bit like this. So if we're going to be building with mud, is it possible to still make it look beautiful? And I did some research, and it turns out that it actually is. These things here are also balls of mud. This is these things exist in Japan. They're called dorodangos, and they're very shiny balls of mud that school children create by gathering mud together, rolling it into a ball, and then polishing it and adding dust and polishing it until they get something that looks like this. I think they're absolutely beautiful. And so my inspiration as a software developer now is to try and, instead of building balls of mud that look like that, I want my balls of mud to look like this instead. And this is what we call microservices. Microservices really is a way for us to try and achieve this, this goal of beautiful, shiny mud balls instead of the giant mess. So if you haven't heard the term microservice before, the best definition of this I've seen is from Martin Fowler, who says that the microservice architectural style is an approach to developing an application as a suite of small services, each running its own process and communicating with lightweight mechanisms, often an HTTP resource API. And this isn't actually a new idea, it's really a new coat of paint on an old idea. And that's the idea of service-oriented architecture. Now, when I hear the term service-oriented architecture, I think about thousands of lines of XML configuration and extremely complex JBoss application servers and so forth. So really, microservices is kind of SOA with less baggage associated with it. It's an attempt to reclaim the concept, which is good, but separate it from the implementation, which in the past I think has been extremely complicated. So the dream of this stuff is to be able to work, is really about independence. It's being able to build software as independent services, each one of which is responsible for a different area of your business domain. And then, because you're building it like this, you can have independent teams working on those services with expertise in one specific area, but not having to know every detail of how the rest of your system operates, potentially using the most appropriate technology for that problem space as well. You can get independent releases, so you can release just individual services without having to release everything all at once. And a really key goal here is having total encapsulation of the data that is owned by a service. So if your service is the only thing that knows how that data is stored, you can potentially change the data storage, you can rewrite things, you can optimize things without anyone else having to know that you're making changes. And at Eventbrite, there are specific benefits that we think are worth having, and the reason that we're we're going through this transition. The principal one is that services are an opportunity for us to refactor our core business logic. I mentioned that we've been using Python since 2006, but that does mean that our code base is nearly 10 years old now. And there's some pretty crufty stuff that buried deep in there that we just haven't had a chance to readdress since it was written 9 years ago. And one of the problems that we have is that often an important part of our business logic, for example, placing an order for tickets for an event, is implemented in many different places and potentially implemented multiple times. The code that runs when you buy a ticket through our website might be different than the code that runs when you buy a ticket through one of our mobile applications. And that's terrible. You know, that makes it much harder to maintain that code. So by refactoring into services, we get the opportunity to take that core business logic, put it in a service, and make sure that there's only one implementation that everything else is calling. We're very keen on being able to use isolated databases. It makes scaling the site a lot easier if we have our data split up into different areas and running on different databases, serving different parts of our infrastructure. And also, because part of what we do is handling payments. You know, we handle credit card payments. We're starting to handle things like Biletto. It's important that we can isolate the code related to that so that we can audit it separately for things like PCI compliance. So some of the core tenets that we have when we're thinking about this stuff, first and most importantly, we are very opposed to stop-the-world rewrites. Often you'll see large companies who have a big existing code base and decide that, you know, it's just not working and they want to scrap it and start over. So they'll freeze development on new features for 6 months or a year or longer while building a complete ground-up rewrite. And very often those rewrites fail. You'll hear stories of people wasting over a year trying to get a complete rebuild working while they were trying to maintain the old software, and you end up wasting your time and not actually moving the business forward. And so we have no interest in doing that at all. So whenever we're looking at moving code into a service, it's always in conjunction with supporting additional features or getting some kind of business value out of that as well. So that's the second point there, is we like to deliver incremental value. We like to make sure that as we're doing this, we're able to deliver real sort of customer-facing features and real value to the business as early as possible, and do that incrementally as we continue. And then just a general rule for all software engineers is to always leave code in a better state than it was when you touched it. If you keep on doing that, then over time your code base gets better as opposed to your code base getting worse. So when we build services at Eventbrite, we actually have our own set of tools that we developed for doing this. And to my surprise, I've been keeping an eye on the general community out there, and there hasn't really been a library for this stuff that's taken off and has sort of proved itself above anything else. So I'm sort of hoping that at some point there'll be a really good, widely supported open source library for this. There is the Django REST framework, which we actually use use for some of our API stuff at Eventbrite. But I don't think there's really a winner in terms of service-oriented libraries. So we have our own library and protocol that we developed in-house a few years ago. And essentially, it's JSON data transmitted over a choice of different transport mechanisms. So we have an HTTP transport mechanism. We have an in-memory or library mode, which we actually use for a whole bunch of our services, where you don't even have to make a network call. The Python code is there with our other code, but we call it through an abstraction that makes it easier to split it out into a remote service later on. And we're developing a new experimental prototype based on Redis, which I'll talk about a little bit later. And so then there are three concepts that we think that you have to understand when we talk about our services. So a service itself is a bunch of code in a separate Git repository from the rest of our code base, and it's responsible for an area of the site, a core set of concepts and related functionality. Each service is simply a collection of actions, and actions are things that you can call. You can think of them as being similar to functions or methods on classes. And then finally, services get to define their own specific data structures, which we call containers. And those are very important to the individual service. We'll have things like the event service knows what an event looks like, so it defines the event container. And so we actually have over 20 services now, and new ones are springing up every few months. We possibly have too many services. One of the interesting challenges with this kind of development is you have to figure out where the boundaries should lie between the different services that you're building. But some of the services we have an auth service that deals with user authentication and passwords and OAuth tokens. We have the payment service, which is mostly built here in Mendoza, which handles credit cards and other payment mechanisms. The event service, we're an events company, so there has to be a service that knows what an event looks like and how those are structured. A new service that my team released recently is a pricing service, which deals with all of the logic about how you calculate fees and prices on the tickets that we're selling. There's a webhook service, which I'll actually go into more detail and use as an example now. But we have all of these different services, most of which are maintained by a specific team at Eventbrite. Our engineering teams tend to be between 4 and 8 people, and each of them covering a different area of Eventbrite's domain logic. So I'll dive into one of our services in a bit more detail, just to give you an idea of what these things look like in practice. So in Eventbrite, we have an API which allows third-party developers and event organizers to programmatically access information about their events. And this is a really important part of our product, because for the larger events, for the music festivals with 60,000 attendees going, they inevitably need to integrate with other systems that they have, with their CRM system or their email newsletter or whatever it is that they're using. And part of our API is we have a feature called webhooks, which is something that you're seeing in more and more APIs these days. It's basically a way of you saying to us, whenever somebody buys a ticket or publishes an event related to my user account, send me a message over the internet, like do an HTTP post to my web application telling me that that thing has happened. So it's an alternative to sort of the common pattern where you have to poll an API once an hour to see if anything has changed. With webhooks, you don't have to poll at all. You just wait for us to tell you that something interesting has happened. And so we built webhooks as a service. It's called the webhook service. And I'll show you a few details of that. One of the tools that we have internally is our Soa Explorer. It's an internal tool which shows you, for any given service at Eventbrite, shows you documentation and lets you explore what the actions are and what the containers are, lets you quickly browse and understand what the service can do for you. So this is the API Explorer for the webhook service. It shows that the deployed version when I took this screenshot was version 1.1, and it shows the various actions that are available. So we have an action for get webhook, we have one for hook, which lets you send webhooks, we have get webhook history list. And then if you click through onto one of those, this is the get webhook action. This tells you that it takes 2 arguments. It takes a user ID, which is optional, and a webhook ID. And then in the output, it will give you that ID back again, but it'll also give you a webhook container describing that webhook. If you click through to the webhook container, it describes the actual data structure that you'll get. So it has a list of strings that are actions. It has a created date and a change date as ISO date times. There's an event ID and a user ID that come back as a string. So this makes it very easy for developers who want to start using a service to dive in, figure out how to call it, and start writing code. And this entire interface it's essentially free. As an engineer that builds a service without doing anything at all, this interface will spring up and become available for other engineers. So then, when you're actually calling services from Python code, it looks something like this. You get yourself the Soa client for the named service. So here I've got a client object for our webhook service. You create a job. A job allows you to send one or more action requests to the service. This is where our batching logic works. So you create a job, you call the action on that job. So here I'm saying I want to call the hook action, passing in the order.place as the action and a set of fields. And then you send to the job and get back a response. And then finally, you can see if that response was an error or not. We have error handling baked into all of this stuff. And then you can act on the deep information that came back from the response as well. Then, when you're defining the service, this looks a little bit like a sort of Django class-based views. All services are defined as a server subclass. It has a service name. And then it has this action class man, which essentially hooks code up to those different named actions. So there's the hook the hook actions in there, resend hook, test hook. These are the names that are exposed on the outside of the service. And each of these actions is a simple subclass that defines the arguments to that action, and then has a run method which actually contains the code that you write when you're implementing what the service does. You'll notice that this class has a doc string at the top. That doc string is automatically extracted out and turned into the documentation that you saw in the API Explorer earlier on. So that's a sort of very quick overview of what services themselves look like. But we also have a REST API that we use for these third-party developers who are interacting with our platform, but also for our own mobile applications. And that looks, the API actually is a separate layer from the services. It looks like this. I'll come back to this diagram in a moment, because the obvious question here is, if you've got internal services, why not just expose those directly and allow third-party developers and mobile apps to talk to those, rather than adding yet another layer on top? And the reason that we've done this, the reason that we have an API as a slightly separate concept from our services, is all about maintaining our own ability to make changes to how our code works. When you're thinking about APIs, one of the things, especially when you're thinking about making changes to APIs, one of the things you have to take into account is how easy will it be to change this API once we've launched it. So with our internal services, we control the services, but we also control the client code that's calling those services. So if we want to change how they work, we can make a change on both sides, ship that change, and now we've got new functionality. This gets slightly harder with our own mobile applications. We have applications for iOS and for Android, and while we can ship updates to those, we're dependent on our users to install those updates. So if we want to make a change to how all of these things work, we can ship that change, but then we have to wait for potentially a few weeks, potentially months, potentially longer for our installed user base to upgrade their app so that they can use the new version. And then with third-party developers, with our partners who are building separate software, we have no control at all about when they're going to make those upgrades. You know, they have their own software roadmaps, and we can email them and say, hey, so we want to make this change, and hope that they can get that into their schedule. But realistically, we can't, other than just breaking all of their applications, we can't force them to make those improvements. So the way we work around that is that we have an API layer which exposes our functionality to mobile applications and to third-party developers, and actually to our own JavaScript running on Eventbrite.com. Our JavaScript now calls our services through the API as well. And that API, which we call API v3 because it's our third released API, that API lives as a layer in front of our internal services. So while internally we have a webhook service, an event service, a payment service, a pricing service, the API is just one interface which people can call, and which itself makes calls to those services and then returns data back to those users. We actually have a public API, and then we have a few private methods within there that are reserved for just for our own mobile applications, or some which are reserved for specific partners because they had a very specific request that we needed to fulfill. And so our API, this is built on top of the Django REST framework. It's actually a very thin layer over our internal services. Essentially, it just defines nice URLs for people to call, and it can do a slight transformation on the JSON. So if we need to provide a different representation to our clients than the internal representation that we have ourselves. And we have an API Explorer for that as well that people can use to explore and understand how our API works. And as I mentioned, that's built using the Django REST framework. So we started working with services of Eventbrite about 2.5 years ago. And over the past year, we've really accelerated this process. Most of our features now involve a service in some way or another, and almost all of Eventbrite's development team are working with services on a regular basis. And so we've learned a huge amount over the past year about what works and what doesn't work. So I'll share some of the things that we've learned with you. I'll share some of the things that we've learned now. And first and most importantly, it's really important to provide great tools around this stuff. With services, we didn't want to lay down the law and tell our developers just one day, you must stop building code the way you're building it. You have to switch to services right away. Because our developers working on these different teams have their own priorities. They're trying to ship features to customers, they're trying to fulfill business goals, and getting them to learn this new system is something which you really need to tempt people into. And one of the ways that we encourage people to adopt services was through providing tooling that you get for free if you're building a service. So one example, this is our service version explorer, but it demonstrates that services get graphing for free. Anytime you have a service, any actions that are called are measured automatically using statsd and graphite, and those can be output onto graphs that instantly show you how much traffic your service is getting. You can see which of your actions are slow, which are fast, and if that performance is getting worse or better over time. Just generally get a really detailed insight into the performance of your service without having to write any additional code on top of defining the service itself. Another developer tool we have, this is an internal tool that we call the Tiki Bar, because it's inspired by do you have any Tiki bars in Mendoza? No? That's a shame, they're fantastic. I bet there are a few dotted around Argentina. But so it's styled after a tiki bar with a tiki mask that its eyes glow red in anger at you if the page takes too long to load. But this is a toolbar that appears at the top of every web page on our site if you're signed in as one of our engineers. And it gives you a bunch of numbers about the page, like how many SQL queries it took to load that page, how long it took, what templates we used. And we recently modified that tool to include, actually Ashwini did this piece of work, to include details on service calls that were made on that page and how long they took. So you can see on this page, we had a call to the auth service, we had a call to the geo service calling get location from address, various calls to the image service to generate thumbnails, and then there's a really big call to the get events method on the event service that was retrieving a list of events to display on that page. And this ties into the sort of next thing we learned, which is that service calls are not free. If you've got, anytime you're making a call to a service, there's a whole bunch of additional work involving building a data structure, JSON serialization, sending it over the wire, getting the results back again. So you have to be careful about how many of these calls you make. And the rule of thumb that we've come to is 4 or 5 service calls on a page is fine. Any more than that, then you need to start considering if you're making those calls correctly. Now, and this is a lesson that we learned the hard way through accidentally shipping. At one point, we accidentally shipped change which caused one page to have over 140,000 service calls, which was an absolute nightmare. And that page took, I think it took 4.5 minutes for the page to render. This was not good. So we actually have the capability now for alerting, so we can spot when pages start using way too many service calls. But this also means that being able to batch your calls is essential. So if you're, a great example, if you're showing a page with 50 events on, and you need to generate a thumbnail image for each of those 50 events, you don't want to have to make 50 calls to the thumbnail method on the image service. So if we go back to this slide, you can see that right there it's saying image, and then it says thumbnail, comma, thumbnail, comma, thumbnail, because we actually made a batch request there. We created one job which called the same action multiple times, and we can then turn that into a single call to the service, which returns a bunch of results at the same time. So batching is absolutely essential for keeping for being able to use these things effectively and have good performance. This also means that you shouldn't hide your service calls behind multiple layers of abstraction. A lot of the performance problems we had were because somebody was making a call to a service deep down in a sort of function, in a method, in a class somewhere that was called by a function that was called by another function. So it wasn't obvious when you were writing code at a high level that you were actually going to trigger dozens or hundreds of service calls. So generally, trying to make those service calls as visible as possible in the code is really important. Then another thing that we do, this is a technique that we make extensive use of at Eventbrite, is being able to progressively launch new features and new services using feature flags. So feature flags are a technique which I suggest anyone who doesn't use them should go out and find out more about. They essentially let you say, here's the code, here's a new feature, we're going to turn this feature on for just our staff users to test it out. Okay, that's worked. Now we're going to turn it on for 5% of our production users, now 10%, now 50%, and now 100%. And so a lot of the time when we launch new services, especially to replace older code, we'll do it on this rolling basis. We'll turn it on for 5% of users, we'll keep track of errors, we'll make sure that everything works okay, and if that passes, we'll ramp it up until we're fully deployed. And the related technique that we've been using recently is a technique of doing invisible comparisons. I mentioned that my team recently launched a pricing service, and this is a service which calculates what fees Eventbrite should make on any given tickets that we sell. And if we screwed this thing up, we would almost instantly bankrupt the company, or we'd at least start hemorrhaging money in really bad ways. So to avoid screw-ups with this, what we did is we actually ran our new code in production for over a month at the same time as the old code. So anytime we needed to calculate a price, we'd ask the old code and we'd ask the new code, and we'd return the result from the old code. So the end user saw no difference at all. But we'd compare the two, and if there was a difference between them, we'd save that to a log file so that we can investigate it later. And using this technique, we tracked down dozens and dozens of weird edge cases that we wouldn't necessarily have found just through inspecting how the code worked. And so this invisible comparison feature, especially if you're trying to rewrite existing code, is fantastically powerful on a complex website. Now, the last thing I want to talk about today are some of the sort of current and future developments, some of the things that we're excited about that we're exploring at the moment. The first of those is something which we actually just started using in production, and that's a service message bus. We're using a piece of open source software released by LinkedIn called Kafka for this, which is fantastically powerful and will very easily handle the scale of operations we have at Eventbrite. But the way an event bus works is you have this single this single log file or message queue that runs through the heart of your infrastructure. And services can make announcements on that queue. They can say things like, the event service can say, someone just published an event. The order service can say, someone just placed an order. The pricing service might say, somebody just changed the fee settings on this particular event. And those get published into a message bus that all of the other services can then listen to. So it's a classic publish-subscribe mechanism. And our first sort of real use case for this is actually the webhooks feature that I described earlier. So what we're having is, in the stream we get event published, order placed. The webhook service can then listen to that stream, and when it sees something that it knows someone is interested in hearing about, it can trigger HTTP delivery. And this is kind of magic, because without this, we have to, in order to provide a webhook for order.placed, we have to find everywhere in our system where orders are being placed and instrument those to make a call out to the webhook service whenever that happens. If anyone modifies that stuff in the future, we have to make sure that they update that as well. With a message bus in the middle, as long as that message is being published to Kafka, we know that the webhook service will keep on working. Now, there's a big downside to this, which is that this only works in a world where everything interesting that happens in the Eventbrite codebase is happening in a service, and all of those services know how to publish to Kafka. And we're still quite a way off that. There's still a lot of code at Eventbrite that isn't running inside services yet. So we actually figured out a way of cheating and getting this world of the future, but today, against our existing codebase. We do that using a system that we built, which we call Dilithium. And the key idea around this, we realized that at Eventbrite we use MySQL for our core database, and we have a whole bunch of replicas set up as replica databases which copy across changes made to that master. And we realized that the replication bin log, the binary log format that MySQL uses to power this feature, is actually something that you can consume from Python as well. There's a really nice open source library out there for consuming that stream. So Dilithium is a little piece of software we wrote that listens to that replication stream and turns that replication stream into these events which it publishes to Kafka. So just by plugging this into our existing database, we got a stream of all of these interesting events happening throughout our code base for free without having to write any additional code. So Dilithium listens to that stream, and then it publishes those events to Kafka, and then our webhook service listens to Kafka and can send out deliveries. And in the future, we plan to build a whole bunch of other things on top of this. We can use this for cache invalidation. We can use it for updating search engine indexes. There's a whole bunch of things that you can build really easily if you've got a reliable stream of interesting moments, interesting changes that are happening in your database. Then another thing we're excited about is adding much smarter caching at the service layer. When you're building a caching system, one of the challenges is how do you know when to invalidate your cache? How do you know when your data's gone stale? And when you've got a system that's spread all throughout that ball of mud, it's very difficult to track down all of the places where somebody might be editing an event, for example. Once all of that stuff is going through a service, that service is a much easier place to add caching. The service knows every time someone is modifying something that it looks after, so it can manage the cache itself. And that also feeds into the dilithium stream of events we can use to make smarter caching decisions as well. Then, sort of final experiment that we're developing at the moment is the ability to make parallel service calls. If you know, for example, that the Eventbrite homepage needs to call 6 different services in order to pull together all of the information needed to render that page, it might be that some of that information could be run in parallel. You could be retrieving user profile information at the same time that you're retrieving a list of recommended events for that user, at the same time that you're pulling back the top events in the geographic location you know that they're in. So this is where, this is something that Python, at least out of the box, isn't actually so great at, is running parallel code. You can do it